So starting with question 1, it says find the integral of sine x cos x to the power of 4 dx. Okay, so we're going to integrate this one. So what I'm going to do is start off by using some substitution. Okay, well, I'm going to let u be cos x. Okay, this cos x, that's what I'm going to let u be. Okay, so now we have to find du over dx, the differentiated form of cos x, right? So du over dx is negative sine x. This is one of those basic and most important trigonometric differentiation that you must know. Okay, so cos x differentiate is negative sine x. Okay, make sure you know those. Alright, so I found that du over dx is negative sine x. Now what I'm going to do is let dx be the subject. Okay, so I'm going to make dx the subject. Basically, I'm multiplying both sides by dx and then dividing both sides by negative sine x, and you'll get to this point. It's just some simple algebra. So I let dx be the subject. Now that I've done that, I'm going to go for my integral. Okay, so the integral of that one becomes sine x. I'll just leave that as it is. Now, can you see that cos x to the power of 4? Remember how I let u be cos x? So I'm going to let that one be u to the power of 4. Okay, because cos x is u. And then dx. dx, I let dx be the subject over here. It was du over negative sine x, right? So dx, I'm going to replace that with du over negative sine x. Okay, just like that. Now, hope you guys can see that we can actually cancel these out, can't we? Okay, because sine x over sine x is 1. So that becomes simplified to negative. The negative I'm going to move out the front. Negative integral of just u to the power of 4 du. Okay, now can you see that everything's in terms of u? So I'm going to integrate in terms of u. So this becomes negative 1 over 4 plus 1, okay, which is 5, and then u to the power of 4 plus 1, so 5, okay, and make sure you plus c as well. So that's my integral, but make sure you don't stop there, okay. Remember, I don't want to solve in terms of u, I want to integrate in terms of x, right? That's what the question asks. So I must go back to my x. Remember how u equals to cos x? So this u, I'm going to replace that with cos x. So it becomes simplified to negative 1 over 5 cos x to the power of 5 plus c. And that's my final answer. And that's the solution for question 1. Okay, so I hope you guys can see the pattern. That's my answer. Okay, so have a look, guys. And we'll try another similar question. So question 2 says, find the integral of cos x sine x to the power of n dx. Okay, so again, I'm going to use some substitution. This time, I'll let u be sine x. Okay, I'm going to let u be sine x. So when I differentiate, when I want to find du over dx, it becomes cos x. Okay, so make sure you know that the differentiated form of sine x is positive cos x. Okay, so make sure you remember those. So I've got the differentiated of found du over dx basically. So again, I'm going to do my usual thing. I'm going to let x be the subject, dx, sorry, be the subject. So dx I'm going to put over here. Basically, again, all I did was multiply both sides by dx and then divide both sides by cos x. You should be able to do that one. So I let dx be the subject, which is du over cos x. Okay, so have a look at that. So now that I've got that, I'm going to try go for my integral. Okay, so that integral becomes cos x, I'm just going to leave it as it is, okay? But I can change sine x to the power of n, can't I? Because remember how I let u be sine x? So I'm going to replace sine x to the power of n be u to the power of n, okay? Because sine x is u, okay? Now, the dx, remember how I let dx be du over cos x? So I'm simply going to replace dx with du over cos x, okay? And again, hope you guys can see that we can cancel this out, right? So I'll cancel those out. So I'm left with simply u to the power of n du. Okay, so you can see that now we're in terms of u only, so I'm going to integrate in terms of u. So if I integrate, it simply becomes u to the power of n plus 1 over n plus 1. Okay, or basically 1 over n plus 1 times u to the power of n plus 1. Okay, just merge them together, plus c. Make sure you don't forget plus c. Okay, But I hope you guys can tell me we're not going to stop there. Okay, we don't want to find our answer in terms of u. We want to solve in terms of x, right? So I'm going to integrate in terms of x. Because I've done that, u, remember how u equals to sine x? So I'm simply going to replace that u with sine x. Okay, so it becomes sine x to the power of n plus 1 over n plus 1 plus c. And that's our final solution. Okay, have a look, guys. And that's question 2. Okay, so you can see that's a very similar pattern to question 1. Alright? Okay, let's move on. Question 3. Okay, part A, this one have different parts, so I'm going to start with part A. It says find the integral of cos x sine x squared dx. Okay, so again, I'm going to use some substitution like we always do. So I'm going to let u equals to sine x, okay? You can see that usually the u, I usually let the one that has a power to it be the u, okay? So hope you can see now what we're going to let u be from now on. So u equals to sine x, then du over dx, the differentiated form is going to be cos x, okay? Remember how the differentiate of sine x is cos x? So therefore, just do our usual thing, let dx be the subject. So I have du over cos x is dx. Okay, so I'm not going to show you that procedure. Hopefully that's okay for you guys. So dx is du over cos x. Now that we've got all that, I can go for my integral. So what I'll do is find the integral of cos x sine x squared dx, which is the question. Okay, and go like this. So cos x, I'll just leave it as it is for now. Sine x squared, remember how sine x, I let that be u. So therefore sine x squared is simply u squared. Okay, and then dx, here it is. Dx is du over cos x, remember? I made dx a subject. So I'm simply going to put this into my dx like that. Okay, and again, hope you guys can see you can cancel this out. So we're just left with u squared du. Okay, the integral of u squared du. And you can see that we're now only in terms of u. So I'm going to go ahead and integrate in terms of u. So hopefully this is some simple integration. This becomes 1 over 3, which is 1 over 2 plus 1 basically, times u to the power of 2 plus 1, which is 3, plus c. Okay, have a look at what we've done. And again, hope you guys can tell me that we're not going to leave our answer like that. We must put it in terms of x, right, not u. So I'm going to replace u with sine x, since u is sine x. So the answer is 1 over 3 sine x cubed plus c. Okay, and that's the final solution for 3a. Okay, so have a look. So again, it's another similar pattern to question 1 and 2. So I hope you're getting the hang of this now. That's question 3a. Now that we've completed that, let's go on to the next part, which is part B. Part B asks us to hence, so using the information that we've got in question 3a, it says find the integral of cos x cubed dx. And we've got this boundary between 0 and pi on 2. Okay? But how are you going to go for this integral? Cos x cubed. What I'm going to do, I'll show you what I like to do. I'm going to actually separate that cubic, this one, into cos x times cos squared x, okay, or cos x squared. Alright? And the reason why I did that is because I want to make this cos squared x become 1 minus sine squared x. Okay? Because remember, cos squared x plus sine squared x equals to 1. So cos squared equals to 1 minus sine squared x. And then expand out the brackets. Okay, get rid of the brackets by expanding them. It becomes cos x times 1, which is simply cos x. Cos x times sine squared x is cos x sine squared x dx. Okay? And for those who are still wondering why I'm actually doing this, that's because I want to utilize my part A. Remember, part A said the integral of cos x sine squared x dx is 1 on 3 sine x cubed plus c. Can you see that? That is that. So I don't have to go ahead and do all that integration. I can just use my answer from part A. Okay? But of course I must integrate cos x as well. So integral of cos x is sine x, right? Positive sine x. So I put the sine x out the front first, And then cos x sine squared x, the integral of that is simply over here, which we've got from part A, is 1 on 3 sine x cubed, okay? And I don't have to put the plus c there because I'm just going to apply my boundary by substituting those in. Can you see what I've done? So now that I've got the integral, I'm going to go ahead and now substitute my pi on 2 and 0. Okay, so I'm going to go like this. So sine pi on 2, okay, I'm just putting pi on 2 into my x's. So sine pi on 2 minus 1 on 3 sine pi on 2, because x is pi on 2 cubed. Okay, and minus 0. Basically, if I put 0 into x, it becomes just 0. So I'm just going to make that whole thing 0. Okay, if I substitute 0, everything becomes 0. That's what happens. So really, all I need to do is simplify this part, isn't it? It's like this. Sine pi on 2 is 1, right? You must remember all your exact values. So sine pi on 2 is simply 1. Sine pi on 2, as I said, is 1 cubed, okay, times 1 on 3. That's all I need to simplify. So if I simplify this, it simply becomes 2 on 3. All right, just simplify that and you should get to 2 on 3. And that's our solution for question 3B, basically. Okay, so have a look at what I've done. Can you see that this part, all I did was get it from part A. Okay, and it was really simple to do my integral after that. Okay, so that's the answer. Have a look, guys. Hope that wasn't too bad to understand. Okay, and that was question 3.